Hi, so for today we're going to talk about the laws of exponents. This is still an algebra tutorial video, so we're going to talk about the laws of exponents right here. And here we have 5 laws, but actually I'm going to write up to 11 laws of exponents. So let's get started. Okay, so for example, we have here n and m in this case are any numbers, okay, integers. So for the first one, we have the first law. If we have what we call a raised to n multiplied by a raised to m, we could simplify that as we can get, if they have the same base, okay, which is a, we can simplify their exponents, okay, by simply having a as our base and by simply adding these two exponents. So for example, we have a raised to negative 9 multiplied by a raised to 4. So we can simplify this into a single base, which is a. And then we have negative 9 plus 4. So perform the indicated operation as the property of exponents have here. For the first property, we have a raised to negative 5. Okay? And we can still simplify this if we know the next loss. But for now, let's take this as our answer. So another example is that for number one, we have a squared multiplied by a cubed. Okay, still has the same base, so we can therefore combine this into a single base a. Okay, and then we have 2 plus 3 here. We're going to add, okay, because of this rule, so that we have a raised to 5, and that should be our final answer. Okay, for the second one, we have a raised to n to a certain number raised to a certain number, and then this whole expression is raised to another number m. Okay, in this case, if we have a base, an exponent raised to a certain number of n, and it is still raised to another number m, integer, so what are we going to do is we multiply those. Okay, that's the difference between we have here an add. Okay, we're going to add if that is a multiplication, and if it is raised to a certain number, we're going to multiply their exponents. So for number 2, we have, let's try a raised to 7 squared. Okay, so what will happen is that this should be a 7 multiplied by 2 because it is raised to 2. Okay, not multiplied by 2, raised to 2. So we will be having performing this. So this should be a raised to 14. We multiplied 7 and 2. Another example is that if we're going to have a cube squared, okay, we can simplify that as a multiplied by 3 times 2. 3 times 2 is a raised to 6. So that's our second law for our exponent or properties of exponent. Excuse me. And for number 3, we have, if we have this a raised to a certain integer n divided by a raised to n, it is equal to, we can simplify that as a raised to n minus the n, okay, or we're going to have 1 over a raised to m minus n, wherein a should not equal to 0. Because 0 raised to a number, no, that's not actually acceptable. Okay? So, let's try to have an example. Okay? So, for this example, we might try a raised to 4 over a raised to 11. Okay, so what will happen? So we can write this, compute this using this. So we have to copy the same base since they have the same base. 4 minus 11. This is our n in this case, and this is our m. And by this property, we have here a raised to 4 minus 11. And that is actually what? A raised to negative 7. Okay, if we're going to use the second one, still no problem. So what will happen is that 1 over a, m is what? M is actually 11 minus n in this case, which is 4. Okay, which is 4. So what will happen is that 1 over a raised to 7. And one property of exponent is that if you want to put this into get the reciprocal of this, we can simply what? The reciprocal of this is a raised to negative 7. If we get the reciprocal of this, then definitely we're going to add negative 7. Negative 7, we're going to have the inverse of the exponent here, the sign of the exponent. So hence, still, these two are equal. Okay. Okay. So, for number 4, we have AB raised to a certain integer exponent n. So, since these two are not equal because they have different variables which presumes that they are not equal, so what will happen? The exponent should be distributive. A raised to n, B raised to n. So, what will happen here is that, for example, we have AB raised to a certain number of negative 4. So, we're going to distribute the negative 4. So, what will happen is A raised to negative 4 multiplied by B raised to negative 4. Okay? And another example is that it can be any variable. Okay? This variable is what I've used only to denote that this is a variable. But you can also use X and Y. Let's say XY. Okay? Raised to a certain number, let's say cube. So what will happen to simplify this is that X cube y cube. You see that the exponent actually is distributed for both the variables. Okay? So, for number 5 law, okay, this is check, this is check, this is check. Say, for number 5, so we have a rational here, a numerator and denominator here where a and b are any variables, okay, integer. So what will happen? A, b raised to negative n. So we can get the reciprocal of that. It would be b over a, but the exponent here is changed in terms of sign. So we can always do that. So for us to have an example, so for example, we have here, let's say ab raised to negative 10. Okay? So what will happen is that this is also equal to b over a raised to 10. And we can therefore simplify this by the previous laws of exponent we have studied. This should be b raised to 10 over a raised to 10. Okay? So another one is x over y raised to negative 2. So this is simply y over x raised to 2 squared. So we have y squared over x squared. So if we get the reciprocal, if this is very useful property if the exponent is negative. And sometimes in the problem, it's always asked that we have to eliminate the negative exponent. So this property is useful in obtaining a positive exponent. Okay? So, okay. For the property number 6, let me just check here. So we have, for property number 6, again, still we have a over b raised to n. Again, this is easy. So this should be a raised to n, b raised to n. Given that b should not be equal to 0 because it would be undefined. So still the same, a raised to n, b raised to n. It's just that it is now a fraction. Okay, so example of here, a over b raised to 7. So this is simply a raised to 7 over b raised to 7. Okay, so another example of that is, let's try, it's very easy, x over y raised to, let's say, 6. So we have x raised to 6, y raised to 6. Okay, so for the property number 7, we have here ab, okay, ab raised to negative n. So that is simply equal to 1 over ab raised to n. So what happened here is we have to eliminate the negative exponent. So we get the reciprocal of this function, and then we negate also the exponent. So from negative, it has changed to positive. Okay? So examples of that, is we have AB raised to negative 20. So what will happen? That is should be equal to AB raised to 20, or see, we get the reciprocal of this and change this into a positive exponent. So we can simplify this further by A raised to 20, B raised to 20. Okay? So for number 8, we have 1 over A raised to a negative exponent. Well, that is equal to, if we want to eliminate the exponent, we get the reciprocal, then we have A raised to n. Okay? Such that, for example, we have here a y raised to negative 6, 1 over y raised to negative 6. That is simply equal to y raised to 6, okay, by this property of the exponent. And another one example, we have 1 over x raised to negative 3. Okay? That should be equal to simply x cubed. Okay, another one. Okay, you're not satisfied. 1 over y raised to negative 16. That should be equal to y 16. Okay, you get the reciprocal, then the negative exponent will change into a positive exponent. So another property we have here for number 9. Okay, so we have a raised to a negative exponent over b raised to a negative exponent here. So this should be equal from our knowledge. So we need to eliminate the exponent, so we get the reciprocal of each. So what will happen? B raised to m over a raised to n. Okay? Some examples of that are as follows. So we have a raised to negative 6 over b raised to negative 17. So that should be equal to, if you want to eliminate the negative exponents, so we have b raised to 17 over a raised to 6. So, and again, another example. So we have x raised to negative 3 over y raised to negative 4. So we have y raised to 4 over x cubed. Okay? So, for number 10, property, we have a raised to n, different bases, b raised to m, and raised to k, to a certain number k, integer. So what will happen is still the same from our knowledge about the previous properties. So a raised to n, since this is raised to a certain number k, integer k, so we should multiply it by k, okay, and n times k, and also the b raised to m, it should be multiplied by k also. So that if we have here an example, a raised to 4 times b raised to negative 3, or yes, negative 3 raised to cube, okay, to 3. So what will happen is a raised to 4 times 3 multiplied by b raised to negative 3 times 3. So what will happen is a raised to 12 multiplied by b raised to negative 9. And we can further simplify this, okay, if your professor doesn't want to have any negative integer or negative exponent, I mean. So we have a raised to 12 over b raised to 9. Because we can always get the reciprocal of this, okay? Eliminate the negative sign or exponent in the exponent. So another example is that we have x raised to 12 y cubed raised to 2. Same process. So we have x raised to 12 multiplied by 2, y cubed multiplied by 2. So we have x raised to 24, y raised to 6. Okay? So that is actually how it works. So, and lastly, for this lecture, last property we have a raised to n over b raised to m raised to a certain integer k. So still the same. A, since it is raised to a certain number k, we should be multiplying it both for the numerator and the denominator. B raised to m multiplied by k. So for example, we have a raised to 6 over b raised to 5 squared. So what are we going to do is a raised to 6 multiplied by 2 over b raised to 5 multiplied by 2, so that we have a raised to 12 over b raised to 10. Okay, another example is that we have x cubed over y raised to 10 raised to 3. So what will happen is that x cubed multiplied by 3 over y raised to 10 multiplied by 3, so that we have x raised to 9 over y raised to 13. So that should be our properties. So now we're going to solve some problems involving uh, expressions that involves exponents. Okay, we're going to simplify expressions with exponents. Okay, let's try to solve some problems. Okay, so solve or simplify each expressions and write the answers with positive exponent only. Positive exponents only. So number one, we have the problem. Okay, let's see. 4x raised to negative 4, y raised to 5 cubed. Right. So the very first thing that you're going to do here is to actually simply solve or simplify first what's on the outside exponent. So what are we going to do? Using our properties that we have learned a while ago, what will happen here is that 4 raised to cube. Don't forget that when we are actually having an exponent, still 4 is still what? Is still raised to cube also. Not only the variables, but also the constants. So what will happen? Since this is raised to 3, we have to multiply it by 3 again. Multiplying it by 3 again, then we have y raised to 5 multiplied by 3. So we have to simplify. 4 cubed is equals to 4 times 4, that's 16. Times 4, that is 64. 64. And we have x raised to negative 4 times 3, that's negative 12. Then 5 times 3, that's y raised to 15. Okay? And our direction is to simplify the expression and write the answers with positive what? Exponents only. As we can see here, we have a negative exponent here. So we have still have to simplify that and eliminating that negative. So what will happen is that 64 y raised to 15, we get the reciprocal of this certain x term, so that we are going to eliminate now the negative sign. So, okay, that's one property what we have studied a while ago. So, this should be our final answer. For number 2, we have negative 10 z squared y raised to negative 4 squared multiplied by z cube y raised to negative 5. So, this expression raised to 2 is multiplied by another expression which is raised to negative 5. So, what are we going to do is first, simplify first the both expression. So, we have negative 10, since this is squared, so we have squared. So, this is negative 10 is squared. So, we have z squared. Since this is what? Since this is raised to a certain number, so we have to multiply it by 2 again. And y raised to negative 4, multiply it by 2 again. Okay? And the other expression, we need to do the same. Z cubed times the negative 5 and y raised to negative 5. Obviously, the exponent of this is 1. So 1 times negative 5 is negative 5. So again, simplify. We have negative 10 squared. Negative 10 times negative 10, that should be 100. Z raised to 2 times 2, which is 4. Y raised to negative 4 times 2, that's negative 8. Okay, that's the first expression. Second expression, we have z raised to 3 times negative 5 is negative 15, y raised to negative 5. Okay, so what can we do here is simply what? Since this is a multiplication, so what will happen? 100 z raised to 4, y raised to negative 8. So, what can we do here is to eliminate the negative. Okay? So, the negative exponent. So, by getting the reciprocal of those, we have z 15, y 5. Okay? And if we multiply it to our expression, what will happen is that we have numerator times numerator, 100 z 4 y raised to negative 8 over z 15 y raised to 5. But we have to eliminate still the negative here. So instead, what are we going to do is that we have 100 z 4 over z 15 y raised to 5, which is this, and y raised to 8. So we can simplify things. So what will happen here is that, as you can see here, we have z raised to 4, we have z raised to 15. So according to our property, we can actually what? Okay? We can actually minus the exponent of this in this. So remember, we have a n minus m. If we have a raised to n over a raised to m, okay? So what will happen here is that 100 z 4 minus 15, okay? So that's the z. And we have here y raised to 5, y raised to 8, same base, which is y. And we have the exponent, so we can add them. So what will happen? Y raised to 8 plus 5 is 13. Simplifying, we have now 100 z raised to negative 11 over y 13. Okay, so the negative sign here is very easy to remove by getting the reciprocal of this. So what will happen is 100 over z11 y raised to 13. So this should be our answer for this example. So for our next example, we have for letter C. Is this letter C? Number 3, I mean. Not letters, but numbers. So for number 3, you have to simplify this. N raised to negative 2m over 7m raised to negative 4 n raised to negative 3. Okay? So the first thing here is, again, we have to eliminate the negative exponents so that we can bring down n raised to negative 2. And we can bring this m raised to negative 4 and n raised to negative 3 up. Okay, so what will happen is that we have m here, which is this m, and multiplied by m raised to negative, or I'm sorry, that is 5 or 4, m raised to 4, because we get the reciprocal. Then we have n cubed over, we have 7, which is this, and we bring down this, we have n squared. So simplifying, we have m raised to 1, okay, multiplied by m, that is m raised to 5. And by this property, we can simplify these two, okay, n cubed and over n squared. So we have n cubed minus 2 over, of course, 7. So simplifying that, we have m raised to 5. And 3 minus 2 is simply n over 7. So we have this answer, okay? No negative exponents. Very simple answer. So we have number 4. We have 5x raised to negative 1 y raised to negative 4 over, we have 3 y raised to 5th raised to negative 2, okay, x raised to 9. So what are you going to do here? Well, of course, we need to still, again, we can do the same thing as here, okay, for the get the reciprocal. Okay, that's good. Or we can also do that. So first, in order for us to eliminate the negative exponent, we need to bring these two down and we need to bring this up. So what will happen? We have 5 multiplied by 3y raised to 5 squared. Okay, and we need to bring down these two. So we have x raised to 1, positive 1, y raised to 4, x raised to 9. So we can simplify this. So we have 5, we have 3 squared y raised to 5 times 2, okay, because this is squared, okay, raised to 2 over x times x raised to 9. So we have x raised to 10, we can add them. So we have y raised to 4 here, okay, and we can simplify this as 5 times 3 squared is 9 y raised to 10, okay, over x raised to 10 y is times 4 or raised to 4. So we can distribute this 5 still to simplify our equation. We have 45 y raised to 10 over x raised to 10 y raised to 4. So we can still simplify this y term. So what will happen is 45 y raised to 10. Okay, this is in denominator. So according to our property, we need to what? Subtract that. So y 10 minus 4 over x raised to 10. So we have 45 y 10 minus 4 is 6 over x raised to 10. So that should be our final answer for this item. Okay, let's proceed to another one. I have two problems left. So we have here z raised to negative 5, if I'm not mistaken, okay, over z raised to negative 2, x raised to negative 1, and we have raised to 6. So what are we going to do here is that we cannot simply bring down this one and bring down this up. So we have first to what? To distribute this exponent, okay, inside. So what will happen since this is raised to 6? So it should multiply with our exponents. Okay? So you have z raised to negative 2 multiplied by 6 and x raised to negative 1 multiplied by 6. So we have z raised to negative 30 over z raised to negative 12, okay, times x raised to negative 6. Okay, then we can do, okay, the reciprocal to eliminate again the what? The negative exponents here. So these two, we need to get the reciprocal and also this. So what will happen? We have z 12 x raised to 6 over z 30. Okay, raised to 30. So what are we going to do is simplify these two. So z 12 minus 30, okay, x raised to 6. So what will happen? We have the z raised to 12 minus 30 is negative 18 x raised to 6. So according to our problem or instruction, we should not have a final answer that has a negative exponent. So what are we going to do is simply get the reciprocal of this to eliminate this, the negative exponent. So we have x raised to 6 over z raised to 18. So that should be our final answer. And for the last problem, so we have 24 a cubed b raised to negative 8 over 6a raised to negative 5 b squared, or negative 2 raised to negative 2. So what are we going to do here is to use the property of the negative exponent here. Okay, so what are we going to do is what? We need to eliminate the negative 2 here. So if we get the reciprocal of this whole term, okay, so what will happen is that this would be a positive square. Okay, so but first of all, before that, okay, we can simplify this 24 over 6. Okay, so the 24 over 6 is actually 4. But we can still do the same later on, okay? It will not affect our equation. So let's try to still, we have 24 over 6 here. Okay. So what will happen is that we need to get that 6a raised to negative 5b over 24a cubed b raised to negative 8. So you notice that we didn't actually what? We didn't actually eliminate the exponent when we get the reciprocal because we are concerned in eliminating the negative exponent here. So this should be squared. Okay? So simplifying, again, if we need to simplify this, so what are we going to do? We have 6 squared a raised to negative 5 times 2 b squared over 24 squared. Okay? A cube multiplied by squared 2 b raised to negative 8 times 2. Okay? So as I have said a while ago, we can actually 36 over 144. So 6 squared. So we have 36 a raised to negative 10 b squared over, we have 24 squared. Okay? 24 squared is how much? 24 times 24, we have 16, 1, 8, 9. So we have 8, 4, 48, so 6. We have 17, 1, 5, 7, 6, if I'm not mistaken. So that's 24 squared. I think we're correct. 576. Okay. So we have now a raised to 6, b a negative 8 times 2 negative 16. Okay, we need to simplify this one. So simplifying this one, we have 36 over 576. That should be, if we divide 576 by 36, we should get 16. So 36, so what will happen here is that this would cancel. Okay, this should be 1 and this should be 16. Okay, so what will happen is that we are left with a raised to negative 10 b squared, okay, over, we have 16 a raised to 6 b raised to negative 16, and we can eliminate the negative exponent so that we have b raised to 16 here, okay, multiplied by b squared over 16 a raised to 10 multiplied by a raised to 6. So we have b, okay, 16 plus 2, okay, because this is multiplication and not raised to another number, so we have to add the exponent. The same also on the denominator, a raised to 10 plus 6. So we have b raised to 18 over 16 a raised to 16. So that should be our final answer, and our final answer does not involve any negative exponents. So that should be our final answer. And I do hope, guys, that you have learned something for today about laws of exponents, and hope to see you soon again on the succeeding or on the next videos. Thank you so much for listening, and God bless.